So my name is Brendan, and I'm going to be doing the physics problem 18 for week 1. So the problem states that two-point charges have a total charge of 560 microcoulombs. When placed 1.1 meters apart, the force they exert on each other is 22.8 newtons and is repulsive. What is the charge on each? So we know that we have two charges and they're repulsive, so they both have the same charge. So in my drawing, they're both positive charges. They're placed 1.1 meters apart. So from Coulomb's law, we know Coulomb's law is force is equal to K constant times Q1 times Q2 over R squared. So we know that the force is equal to 22.8 newtons. We know that both charges must add up to 560 microcoulombs. And we know that the R is 1.1 meters because they're placed 1.1 meters apart. So this problem is basically plug and chug. So we know that the force is 22.8. We know the K constant is 9 times 10 to the ninth. And then for the Q's, we know that they both have to add up to 560 microcoulombs. So we can say that Q1 is equal to 560 minus Q2. So we can plug these in. So we know Q1, and then we know, or we can say Q2 times 5.6 times 10 to the negative 4 minus Q2. So then this is all over R squared, which is 1.1 squared. So basically we just need to simplify all this mess, and then we get Q squared minus 5.6 times 10 to the negative 4th times Q plus 3.0653 times 10 to the negative ninth is equal to 0. So we know that this form is the quadratic formula form, so we can use the quadratic formula to solve for Q. So 5.6 times 10 to the negative 4 plus minus square root of 5.6 times 10 to the negative 4 squared minus 4 times 1 times 3.056 times 10 to the negative ninth. And then this is all over 2. So we can simplify this even further. If we simplify this even further, we get 5.5447 times 10 to the negative 4. This is from 0.0110 divided by 2, which is what we would get from the quadratic formula. So we solve for one of the charges, and to get to the other charge, we subtract it from 5.6 times 10 to the negative 4, because they both have to add up to this total charge that they give you in the problem. So we got one of the charges, so by subtracting it from the total, we can get the other charge, which is 6 times 10 to the negative 6. So it doesn't really match up with the answer in the answer key, but it's a slight rounding error, and it's approximately the same. So our two charges would be 5.5447 times 10 to the negative 4 coulombs and 6 times 10 to the negative 6 coulombs. And that's it.